Okay, so we're on page 66. We're looking at cases where we're comparing two population proportions. And so basically what we're looking at is what we had before, just with two proportions instead of one. So we're going to have a count and we're going to have a total. So total number of individuals in a set and a number of successes, but two sets. All right, so that kind of coincides with the assumptions, two independent simple random samples, but everything else is the same as the one population proportion conditions for binomial distribution are satisfied in those weird math operations. All right. So since we're testing claims about two populations now, or the relationship between two populations, it's not just p equal to 0.5 or 0.6 or whatever. It's the population proportion for one group is going to be either equal or in some way not equal to the population proportion for another group. But everything else in the process is the same. So we're going to go to the calculator, we're going to look for p-values, and we're going to use that to draw a conclusion. All right. The relevant hypothesis test here in the calculator is the 2-prob-z test. So for one population proportion, it's a 1-prob-z test. Now it's a 2-prob-z test. All right, so that part should be easy enough to manage, I think. All right, so a study was conducted to determine if the ratio of passing touchdowns to passes attempted by Peyton Manning, I guess, had increased between the years of 2003 and 2004, so I'll take that as a typo. In 2003, Manning attempted 566 passes, 29 of which were touchdowns. In 2004, Manning attempted 497 passes, 49 of which were touchdowns. Use a 0.05 significance level to test the claim that the population proportion of touchdown passes has significantly increased between the years of 2003 and 2004. All right, so what I'm going to do is just like what I've been doing before or all along, is I'm just going to take note of the relevant pieces of information here. So we have two groups. We have 2003 and we have 2004. In 2003, that's my first group, we had 566 passes, 29 successes. You don't have to know what a touchdown is in order to kind of get the idea that we're defining that as being a success. But if you don't know, it's a score, it's some kind of score. So like if you equate it to soccer, I guess it's the equivalent of a goal. You know, in basketball, it's the equivalent of getting a basket. You know, but it's a positive outcome. All right. So N2, 497 trials, 49 successes. Alpha is 0.05, so I'm just going to jot that right down immediately. 2-prob-z. I'm just kind of hopping around a little bit because we have this information available, so why not just throw it in? So HO. Well, HO is the equal sign. It's not going to change. All right, so P1 is equal to P2. The population proportions, the default assumption is that there's no difference between the two. Even though if you do the simple math, 29 divided by 566 is not going to be the same as 49 over 497, because 49 is more successes out of 497, which is less trials, so it's going to be a higher percentage. All right, we want to know whether the proportion of touchdown passes has increased between those 2 years, 2003, 2004, which would mean that the population proportion, I'll just write prop, should be smaller before than it is after. All right, so P1 is going to be less than, poor quality, less than symbol, less than P2. All right. This is probably, I would even kind of suggest that the population proportion cases are the easiest ones when dealing with the calculator, because if you go to stat test, 2-prob-z test, it's tailor-made. All right, you just got to put the numbers in the right order. So 29 out of 566 and 49 out of 497. with a less than symbol. All right, and then we go to calculate. All right, so again, all I need is the p-value. Got a lot of other information here, but we're just using the p-value approach, so 0.00157. All right, so the p-value is certainly less than alpha. Regardless of what alpha is, this is so small that it's going to be less than any alpha that we would select, 0.01, 0.05, or 0.10. All right, so there is sufficient evidence to reject the claim that the population proportion of touchdown passes I'm going to run out of room, so is equal. So I'm just going to go off the table here between 03 and 04. What do we do? Like a little apostrophe? I don't know. I'll take that as an Easter egg or a typo or whatever. Just let me know what, I want to write 2003, the abbreviation. Is it an apostrophe? What kind of notation do I use for that? I can look it up, but I don't want to. I want you to tell me so I can give you bonus points for it. At the 0.05 significance level, therefore the claim of a significant increase, so the word that's already in there, the claim that there is a significant increase, sig now, inc now, because as you write more and more of these conclusions, you start getting lazier and lazier. Understandable. And also, I'm going to run out of room if I write the full words. There is a significant increase between 03 and 04. There was sufficient evidence to reject the null, so null is incorrect, making the alternative correct. So that the claim that there's a significant increase, I'll bring this in a little bit so it's easier to see, is going to be, oh, I almost said false. That would have been outrageous. It's going to be true. All right. So that, and really any word problem that's structured like that is going to follow the same exact process. So one example and done. I mean, I can hit you with like 20 more examples. It's not going to make the situation any better. So study this example and you'll know how to do these kind of problems. And so there it is. That was page 66. Execute order 66. That would be your